Good morning, students. Today we are getting into the Unit 3 Introduction to Machine Learning Concepts and Algorithms. So, now we should know what is machine learning, what is a machine learning concepts, how it works, and how to write the algorithm using machine learning. What is machine learning? Machine learning is a subset of artificial intelligence that enables system to learn from the data. So machine learning, it is a subset of artificial intelligence which learns from the data, identify the patterns and make decision with minimal human intervention. So this is called machine learning. It is a subset of artificial intelligence and learn from the data, identify the patterns, how the data has been arranged or how the data has been in what range is that the data. So it will predict, identify the pattern and make decision with minimal human intervention. Instead of being explicitly programmed for a task, machine learning algorithms use statistical techniques. So machine learning algorithms use statistical techniques instead of explicitly programming the language, the algorithm. The machine learning algorithm use statistical techniques to allow computers to improve their performance based on the data, experience data. What is machine learning algorithm? It is a mathematical procedure or set of rules used by the computers to analyze the data, identify the patterns and predict and make prediction. So first of all, we need to give a data to the system. The system will try to learn this data and analyze the data, identify their patterns and make predictions on our decision without being explicitly programmed for specific tasks. Explicitly programmed for specific tasks. This is how the machine algorithm works. Mathematical procedure or set of rules used to analyze the data. So the key concept on machine learning, first one is data, the second part is model, third is training, fourth one is algorithm, fifth one is prediction and sixth one is evaluation. So coming to the data, input to machine learning systems. So it is a subset of the artificial intelligence. Machine learning can be structured or unstructured. Okay, so what is structured data? Like data sets, databases, tables or structured. Unstructured, so you also can get the information from the images or maybe text or audio. So this is a unstructured one. This is a structured one. And coming to the labeled data and unlabeled data includes both input and the correct output used in the supervised learning. So the labeled data have both input and output, includes both input and the correct output. It has been correlated. So the input and output are correlated. In unlabeled data, we have only the input without output used in the unsupervised learning. So we have a supervised learning and unsupervised learning. In supervised learning, so we have a correlation between the input and output. Whereas in unsupervised learning, we have only the input data. We don't know how the output has been correlated with the input data. Hope you understood. So coming to the model. A model is a mathematical representation. So here the machine learning algorithm is a mathematical representation that makes prediction or decision based on the data. So it is built by training on data and adjusted to minimize the data, minimize the error. Okay, training on data. So usually what we'll do, we will train the data, most probably 70%, and then we will have it testing. Okay, testing on 30% for evaluation. So it's built on training on data and adjusted to minimize the error, the model. Coming to the training, the process of feeding data to an algorithm so it can learn patterns. The process of feeding the data will be feed into the system. The process of feeding the data to an algorithm so that it can learn patterns. So how the data has been correlated. Okay, so involves adjusting the model internal parameters to best fit the data. Coming to the algorithm, a set of rules or instructions used by the model to learn from the data. There are different types of algorithm. Okay, one is linear regression, decision tree, neural networks, k-means. We will see one by one later in elaborately. So, okay, and coming to the prediction, once trained, a model can predict the output for a new unseen input. Okay, so these are the steps process. So first of all, the data collection, the data that need to be given to the system, and then model, and then training the data. Okay, training the model and even algorithm by giving the data, and algorithm we need to choose the algorithm. What is the depend on the data type, and then prediction. Okay, once trained, a model can predict the output. Okay, and coming to the evaluation. So that is a last part. Testing how well the model performs. Common matrices, accuracy, precision, recall, F square or mean square error. So we can have a trade-off for the evaluation, because sometimes we may be more towards the accuracy or maybe to speed. Okay, so we need to trade off. We need to find it out which one is better for our case. Okay, so what is a recall? What is F1 square? The accuracy and precision you may be knowing. What is accuracy? Okay, the accuracy is nothing but, so for example, I want a more accurate. Let's say I just throw a what do you call it, arrow at the center of the circle. So one time I just do it. Okay, it's accurate. So my arrow which has been thrown out and then center of the circle, it has been accurately pinpoint. It's accuracy. I mean, knock the thing. Okay, it's accuracy. Whereas the precision is continuously. Okay, that is two times or three times I just throw it out. So frequency depends on the frequency. How many times even I throw, accurately pinpoint the thing. That is called precision. Okay, so the precision is very important. Like for example, what we do is actually take a concordant values in while doing a titration, right? So the precision is a how many times it just accurate. Okay, it's a called precision. If you depend on the frequency. And coming to the recall and F1 square, I'll explain to you what is recall. Recall is nothing but true positives divided by true positive by false positive. For example, I can give an example. Let's say the patient, 100 patients are found to be cancer patients. Okay, so let's say my model predict only 80 patients. Then it's a true positive is 80 and false negative is 20, right? So the recall is true positive 80 divided by 80 plus 20. So that means 80 divided by 100 is 0.8. So the accuracy is only 0.8%. Okay, so this is how the recall has been calculated. And coming to the F1 score, F1 score is the harmonic mean of precision and recall. It provides a balanced measure when you need to consider both false positives and false negatives. F1 score is equal to 2 into precision into recall divided by precision plus recall. It is an harmonic mean. Okay, it is an harmonic mean of precision and recall. That is called F1 score. So what does it mean actually? The common matrix evaluation based on the accuracy or precision or recall or F1 square or mean square error for regression. Okay, so depending on which one is more accurate, that's what it means. So coming to the types of machine learning, we have supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So what are they actually? So what is the description of supervised learning? As I told you, the data, okay, the input is equal and also the output has been correlated in a supervised learning. Learns from labeled data. Okay, this one is a learns from the unlabeled data. The example, for example, for supervised learning, email spam detection. Okay, so in Gmail, actually, you could be able to see the spam email. So it will identify the spam mail and it will segregate the things. So learn from the labeled data. Okay, unsupervised learning learns from the unlabeled data, customer segmentation, topic modeling. That are the examples for unsupervised learning. Coming to the semi-supervised learning, combines small label data with large unlabeled data. For example, face recognition. Okay, let's say only a few people you already recognize and then store in the system. So the face, only the identified person is already known. But if you people have been walking on the road, okay, for example, in China, in the open common place, they will have a face recognition. Okay, so the face recognition, however, I have given the data earlier as a labeled data. The unlabeled data may be a large quantity, okay, which for example in India we may not, many people may not be recognized by the thing, but however nowadays the Aadhaar card is there, the face recognition has been given for everyone, even in India also, right? So it's not the case actually. What I said is not correct. I mean in India also the people have been stored the data, the face recognition. So the people who don't have the face recognition pictures earlier, obviously it's very difficult for them to identify in a common place when they walk, right? So the face recognition with a few labeled images, so semi-supervised learning, combines small labeled data with large unlabeled data. Okay, so for example, a country which have only a limited number of face recognition, the other they don't have. For example, in India we have a Aadhaar card. So in that case, we have all the information we already have for 100 crore people. Okay, let's say the country does not have that information. Large quantity of people will be no unknown the face recognition. Only a small amount of data may be realized. Okay, so in that case, we can go for semi-supervised learning. Okay, so machine learning coming under semi-supervised learning combines small labeled data with large unlabeled data. Reinforcement learning learns by interacting with an environment to maximize the rewards. Okay, for example, in game. Okay, so when you go and eat, okay, you will be, I mean, casting the point 100. Okay, you will be rewarded. Okay, so game artificial intelligence. So in that type of a thing, they will use the reinforcement learning. Okay, so example of machine learning application in healthcare, finance, retail, manufacturing, transportation. Healthcare, predicting diseases, drug discovery. Finance, credit scoring, fraud detection. So machine learning application in finance is credit scoring as well as the fraud detection can be identified. Retail, recommendation system, Amazon, Netflix. So maybe you might have seen actually, you might have searched in Google and the same thing will be reflected in your Facebook. Okay, sometimes, for example, I was searching in what is the shoe price of Tata slipper or shoes, okay, and what you call Adidas or something. When I try to find it out, okay, so the price of the car, the what we are searching in the Google may be reflected in the Facebook. Okay, is a recommendation. So the retail, so they will understand this person is looking for this information in the Google. Obviously, this will be reflected back everything. So it's a machine learning application, retail, okay, recommendation system by in through Facebook. Okay, so manufacturing, predictive maintenance, quality control. Okay, machine learning application is there. Transportation. That's why what is the application of machine learning, predictive maintenance as well as the many system, complex system can be easily studied by the machine learning applications in chemical engineering. Transportation, self-driving cars and traffic prediction, robots. Okay, this is all application of machine learning only. Okay, so common machine learning workflow, problem definition, okay, and then data collection, data pre-processing. For example, if we have noise and everything that we have seen in the last 2 unit, okay, how to remove the noise and other things before we fed into the models. Model selection, so the algorithm, okay, so we need to choose which algorithm we need to choose, whether we need to go for a random forest, support vector machine, or regression models, or linear relay model. Okay, that we'll see actually step by step. Okay, and training the model by giving a data. Almost 70% of the given data, I mean collected data, can be given to the train, and 30% can be evaluated. Okay, hyperparameter tuning. This is very very important. What is hyperparameter tuning? In machine learning, hyperparameters are configuration settings used to control the learning process. They are set before the training begins and cannot be learned from the data directly. Usually, from the data only the algorithm learns actually the models. Okay, so but here the hyperparameter is initially we are giving the configuration setting. For example, in a washing machine, we will set the what how much amount of water is supposed to be taken, what is the swing speed. Some preliminary data we will set it. Am I correct? In washing machine before we start to do the things. So this is an example for hyperparameter tuning. That means we are giving a data in a pre-hand so that this algorithm, I mean the system will try to instead of understand from the data. So this will be taken from the hyperparameters. Okay, hope you understood. Deployment and monitoring and updating the models. And challenges in machine learning, overfitting and underfitting. These are the two things. So as you know, the overfitting is the model performs well, but however, on training the data, but poorly on new data. Well on training data, but poorly on the new data. So the model performs well for the data which has been given, but the new data it will not fit. Okay, overfitting. And underfitting is the thing, model is too simple, okay, and cannot capture the pattern. It's underfitting. So that, for example, in the last case which we have seen, A4 score, right? So they, because of the false prediction, 20% of cancer patient, which I told you, right? It's an underfitting model, 80% only. So usually if it goes for 85% and above is well and good. Okay, the model is supposed to be exactly supposed to be 50% error or less than that, it will more fitted, right? So bias and variance trade-off, balance between the simplicity and complexity. Okay, which one is better? Balance between the simplicity and complexity, and the data quality and quantity, interpretability. Some models are like black boxes. So these are the challenges in things. So obviously the machine learning may overfit or underfit. We need to give a trade-off between the bias and variance. Okay, that is a simplicity and complexity. Okay, data quality and quantity, that is very important also, and also the interpretability in the sense some models are like black boxes. Okay, so we need to go for a deep learning, okay, or like black boxes. So supervised learning algorithm. So categories of machine learning algorithm are two types. One is a supervised learning algorithm, unsupervised learning algorithms. So we will see one by one, and the example with the chemical engineering examples also I have given here. Okay, learn from the labeled data. So data with input and output pairs. So it has been correlated. Labeled data will be correlated between the input and output pairs. Goal, predict output from the new input. So, algorithm for the supervised learning, linear regression, logistic regression, decision tree, random forest, support vector machine, k nearest neighbors, and naive Bayes. So, here out of which we will see an example for random forest and support vector machine when we need to go for this type of thing. Okay, with respect to chemical engineering, with the chemical engineering examples, we will see. Okay, coming to the linear regression, use cases predict continuous values. Example, house prices. Okay, so the prices of the house will obviously will be linearly increasing, right? So linear regression, logistic regression, binary classification. Okay, so whether the mail is correct mail or spam detection. Okay, so models probability of a binary outcome. So logistic regression, yes or no. Okay, you can go or you cannot go. Okay, so this is the logistic decision. Decision tree, classification and regression. Use cases classification and regression. Random forest, improved decision making. Okay, so we'll go for a improved decision making, random forest, support vector machine, classification. I will give an example for these two things. One is a support vector machine, fault detection in a distillation column. Let's say you have a distillation column, may develop faults like flooding, weeping takes place. Okay, when the flooding takes place, when the air flow rate is not enough. Okay, obviously the flooding of liquid from the tray will take place. Weeping in the sense the air flow rate is very low. Okay, through the thing, liquid will be passing through. Weeping. Okay, so weeping or tray damage may take place. Okay, these are the fault part. These faults cause abnormal patterns in the variables such as temperature profile, reflex ratio, top and bottom product composition, column pressure. Okay, so when you have a fault detection, then we go for support vector machine. So excel for classification task, whether it's a normal or faulty. Okay, so support vector machine coming under a classification task. That's what I told you in the previous case. Effective in high dimensional spaces. Okay, this is support vector machine is effective in high dimensional spaces, like especially when features are engineered with from sensor data. For example, we temperature in the distillation column, pressure in the distillation column come from the sensor data. So in that type of high dimensional spaces, we can go for support vector machine. Works well with the limited labeled data sets. Okay, when your labeled data sets are very limited. Okay, unlabeled data set means okay the input and output is not correlated. Labeled data set, okay, is a supervised learning coming under a labeled set. So input and output can be correlated. Works well with the limited labeled data set, which is common in the industrial diagnostics. So train an SVM support vector machine model to classify normal operation with the versus different types of faults. So in that case, we can go for a support vector machine algorithm. So you understood when we need to go for the different types of algorithms. Okay, and coming to the random forest. So predicting product yield in a chemical reactor. Let's say you have a reactor. Okay, in a reactor design or process optimization task, engineers want to predict the yield of the product based on the various operating parameters like temperature, pressure, concentration of the reactant, catalyst concentration, feed flow rate, reaction time, and so on and so forth. Okay, in that case, it can handle non-linear relationship. Random forest can handle non-linear relationship between the input and the output yield because it's depend on the different parameters. It may be a polynomial or what you call exponential. So it's an independent, it's a non-linear relationship. It provides future importance, helping engineers understand which factors most influence yield. Okay, it is robust to noise and overfitting. Okay, it's very accurate and robust to noise and overfitting. Okay, so it's not underfitting. Okay, especially when data is limited or as measurement errors. Okay, so using historical plan data or a random forest model can be trained to predict the product yield. So with the in the historical data, we can predict the product yield, which helps in optimizing the process without running costly experiments. Underline the word costly experiments. So with the input data, with the previous data, we can use this model. Okay, for this to find the reaction yield in chemical engineering, we can go for a random forest. Unsupervised learning algorithm, unlabeled data, work with the unlabeled data. Okay, in the supervised learning algorithm, we will work with the labeled data. This one is worked with the unlabeled data. So, what are the different types of algorithm in unsupervised learning? K means clustering. Okay, customer segmentation. Groups data into K clusters based on the similarity. Hierarchical clustering. Principal component analysis is nothing but dimensionality prediction, which we have already discussed in the unit 1 and 2. Principal component analysis try to reduce the number of variables. Dimensionality reduction. Okay, DB scan. DB scan is for spatial data analysis. Okay, so these are the different types of algorithm which can be used for the unsupervised learning, unsupervised learning model. Okay, using unsupervised learning algorithm. Semi-supervised learning algorithm. Okay, so use a small amount of labeled data and large amount of unlabeled data. Okay, so which I give an example for face recognition. I told you, right? Okay, so useful when labeling the data is expensive. So the labeling data is expensive. When you have a labeling data is expensive, we can go for semi-supervised learning. We have a small amount of labeled data and a large amount of unlabeled data. It's a combination. Whereas in a supervised learning is a labeled data, unsupervised learning unlabeled data. Whereas semi-supervised learning is contains both labeled data and unlabeled data, but the small amount of labeled data, large amount of unlabeled data. When you have a labeled data is cost expensive, okay, costly, okay, expensive, then we can go for a semi-supervised learning with that small labeled data, large amount of unlabeled data. Self-training using base classifiers like decision trees or support vector machines with both labeled and unlabeled data. Self-training using base classifiers like decision tree or support vector machines. Okay, coming to the reinforcement learning. So, reinforcement learning algorithm have different types: Q learning, SASA, deep Q networks, policy gradient methods. So, game playing robotics are coming under Q learning, learned by interacting with an environment. This one is like how the robot works. Okay, for example, Q learning, you see game playing. Okay, game playing learns a policy for action selection. Okay, so game playing, Q learning is there from the playing learn a policy for action selection. So, for example, SASA update the policy as it learns. So, from the mistakes, okay, try to learn the things, something like that. Learn a policy for action selection. Okay, so SASA is a similar to Q learning. Okay, so this is coming under the reinforcement learning algorithm. Choosing the right algorithm, how to choose the algorithm, whether I need to go for a supervised learning algorithm or unsupervised learning algorithm or supervised learning algorithm or reinforcement learning algorithm, how to choose which algorithm is best suited for my case. So the type of problem we need to know: regression or classification, size of data. Some algorithms scale better than others, data quality, noisy or clean data, interpretability. Do you need to explain decisions? Okay, accuracy versus speed, trade off between the application, between the cases, depending on the application. So choose the right algorithm. These are the factors which we need to check. So what is our problem, type of problem, size of data, data quality, what is the data quality, whether it's noisy or clean data or missing values, interpretability. Okay, how do you want to interpret the final conclusion with the input and the output, and accuracy versus speed, which one is better for suited for trade-off, whether you want to go for accurate or you want to go for speed. Okay, so trade-off between the application. So based on this condition, then only you could be able to choose the right algorithm. So reinforcement learning algorithm we have seen, supervised learning algorithm and supervised learning algorithm. Very good. So how algorithm work? General workflow, collect and prepare data, choose algorithm based on the data type and problem, train the model, evaluate the model, accuracy, precision, recall, F1 score and things like that. Okay, and then optimize, tune hyperparameters, class validation. Okay, tune hyperparameters. I even give an example. Okay, example, the data has been set. Okay, from the data, it will not understand the thing. Before that, we are giving the system the input. Okay, it will not try to collect the information from the data. Okay, so deploy and monitor, put into production. So that's why I give an example for hyperparameters. Is a preliminary data which has been given in the for the washing machine before we operate, like the how much is the time we need to operate, or how much is the amount of the spinning period, everything we can fix it, right? So similarly, and coming to the application of algorithm type, so healthcare, what is the type of algorithm we can go for? Decision tree, support vector machine, for retail, K-means, from principal component analysis, we can go dimensionality reduction, okay, transportation, reinforcement learning, okay, and then marketing, naive Bayes. So these are the types of algorithm we can go for, okay. So application is for healthcare is disease prediction or diagnosis, for finance, fraud detection, and credit scoring, retail, customer segmentation, demand forecasting, transportation, autonomous vehicles, okay, marketing, sentiment analysis, or email classification. Okay, sentiment analysis. Okay, obviously based on the marketing, because how we market the things. Okay, that is very very important. Okay, so introduction to machine learning algorithm, common issues and consideration, maybe overfit or underfit. Model is too complex for the overfitting, fits training data too well, but new data will not get it exactly fit. That is a overfitting issue. Underfitting, models is too simple, fail to capture the pattern. Bias variance trade-off, balance between the simplicity and complexity. And computation cost, some algorithms require more time and memory. That also we need to look into the things. Okay, and scalability, will it work well for a large data sets? So these are the common issues and considerations that need to be considered after the modeling research subtype. Okay, machine learning algorithms are the building blocks of intelligent systems. Choosing the right algorithm involves understanding the nature of your data, the type of the task. So that's why there's some of the few factors which I told you, the amount of data which need to be collected. Okay, so how to choose the day, type of pad problem. Okay, choosing the right algorithm, type of problem, size of data, data quality, interpretability, and accuracy versus speed. So with this, um, I want to conclude today's section regarding the introduction of machine learning concepts and algorithms. We'll see you in next video shortly.